April 25th, 2016. A big philosophy that I see very popular among astronomers is that they look at the solar system and they make it as a system. They say all these objects are related because they all formed as a byproduct of the sun's formation. They're leftover remains from the sun's formation. And they're all the same age and they're all related. Of course, the orbital distances aren't to scale here and the sizes aren't to scale. And of course, they're three-dimensional structures. They're not 2D. But there's a main problem with that philosophy. If you put a big circle around all of them and you say they're all related, you're forced to try to explain all their differences inside of a closed system. But as we all know, all my listeners know, these objects are not related. They're all stars in different stages to their evolution, meaning they're all individual objects. The sun is its own object, Jupiter is its own object, Saturn, Earth, Venus, Mercury, Neptune, and Uranus, and Mars. They're all individual constructs. They're part of a temporary system. So the main philosophy difference is you have permanent versus temporary in their current configurations. Now, the temporary means the orbits will change, and the permanent means the orbits became like this when they came into being, and that they're always going to be like this. So, on one hand, you have limited understanding of nature, of the stars, of the solar system, and on the other, you can branch off and you can have them move about and do whatever you want with them. Now, the only way to determine what's happened to these things is by studying the crust and looking at mass extinctions. Because a mass extinction probably signals that the orbit of the Earth had changed in the past. To take up orbit around a different star would take many tens of millions of years. And obviously, since the Earth would move out of the sun's orbit, it would become, being that it had water on it at the time, it would become a snowball Earth. And all the life on the surface would freeze to death. Everything would die on the surface because it would just be too cold. So that means the creatures that could burrow inside the ground would be able to survive. For the other extinctions, probably something similar happened. Who knows? But it's best to give scientists options. Unfortunately, they put everything into a closed loop. They prevent options from being had. They prevent their mind from looking at things in a new perspective, a new worldview. And another idea I came up with, this might not be correct, but I thought it was really strange. Sure, Pluto is not a planet anymore, but since we know what happens to these things, we can go back to a system with 9 things, a 9-planet system. Because the sun is a very hot new planet. It's as simple as that. Kick Pluto out, adopt the sun. Of course, it's never going to be accepted in my lifetime. As well, I have problems with it because the way I have stars is being differentiated as they evolve, meaning the only dead stars are the ones with huge iron-nickel cores and have highly organized differentiation. Those were ancient stars, but if they're undifferentiated, like Callisto is, they weren't full stars. They're remains of impacts. So we'd have to figure out which ones are fully differentiated and have iron-nickel cores to determine if they were stars at one point. Today is April 26th, I believe, 2016. Hopefully this helps people out a little bit. And Baz, I'll be making another video on the whiteboard explaining how the orbits do change. And I want to overview a new concept with that. It's kind of strange, but it has to be mentioned. I guess it can try to figure out why the magnetic field is off kilter as well as the orbit. But look at it as like one of those goofy balls where you have a core kind of off center, and when you throw one of those goofy balls, you know how one side of it would have a little weight in the ball. Like imagine if you have a basketball and you have a little weight inside one end and you throw it and it wobbles really bad. That's what happens. When you have an orbit change, the wobbling will be so bad it will throw its magnetic field off axis to its actual orientation. And then when it stabilizes, then the magnetic field will begin taking up the same orientation as its rotational axis. So we can determine if an object is undergoing an orbit change if the magnetic field and the axis of rotation are off kilter with each other. But I just had to think of that because there are a lot of options to explain how stars evolve and how they change orbits, and there's a lot more to discover. So you just have to keep an open mind with that. Alright, later.